Here's integrated 3. It's the closure problem 4-134. And it wants you to make, well, here, let's just read it. It is inventory time at the Mathletes Shoe Superstore. To speed up the process, Iris, the store owner, decides to find the value of the inventory by counting the number of pairs of shoes in $30 intervals. She makes the following table. So this part isn't supposed to be on the table, and not that part either, just that. So you can see that she already put the numbers in little increments or bin widths. Like our bin widths are $30. So the problem that I have with this is that we can't, or at least I do not know how to use technology on this one, because it doesn't give us, see, we know that there's 47 pairs of shoes that are in between $0 and $30, but we don't know the prices of each of the 47 pairs. Like there might be two $17 pairs and one $15 pair and an $11 pair and a $19 pair and a $29 pair. Like, and there's 47 different numbers that we don't know the individual numbers for. So I can draw this by hand, and it's actually kind of set up nicely to draw by hand, because if you add up all these pairs of shoes, there's 250 pairs of shoes here. So really we wouldn't want to type in every price of every shoe, because that'd be 250 data points that somebody has to type in somewhere. So I'm just going to do this problem by hand. So this is going to be a histogram. It says make a relative frequency histogram of the distribution of shoes in the store. So the reason I'm covering these numbers up over here is because these are the percentages. And I'm going to show you how to get them, because I'm not going to make like my first bar go up to 47 and my second bar go up to 67, because that's not a relative frequency. Relative frequency gives us some percentages. So to get the percentages that I've already written down here, we're going to say, well, 47 out of, if you add these up, it's 250. We're going to say 47 out of 250. Well, that's 1.88. Okay, and so that's where all these numbers came from. Like this one, I went 67 divided by 250, and I got my number. 60 divided by 250. These are percentages. So in other words, about 18.8% of the shoes are cheaper than $30. About 26.8% of the shoes are between 30 and 60. So hardly any of the shoes are between 210 and 240. It's like 0.8%. That's not even a whole percent. So these are all just little percents. So make a relative frequency histogram. Okay, so I'm going to just do it on a piece of paper. And that's good to be able to do stuff on paper. So I grabbed some graph paper that I just had. And this was a chore because I had to decide. I didn't want my graph to end up really tiny or going off the edge, so I had to actually count, my grid lines and figure out what can fit. So I knew that I had to make it out to 240. So I just counted, like I counted along here, and I found out that I had like 30 grid lines, and I thought, well, if I count by 5, I won't make it. So I counted by 10. 10, 20, 30, 40, 50, 60. So that worked out great. So those are going to be my kind of like my bars, my bin widths. And then since it's a relative frequency, and I just looked at my numbers, I'm like, what should I count by? Like the highest number is 0.26. Well, actually, if you round it, it's 0.27, isn't it? But so I just counted how much room I had here, and decided I could count by, I could go like 0.01, 0.02, 0.03, 0.04. And that actually gives me makes it have enough room to go high enough, because I can count all the way up to 0.30, which is more, that's higher than all these values. So that's a skill in itself. And so now I'm just going to draw the bars. So the first one, from 0 to 30, I'm supposed to draw it up to 0.188. So that's going to be very close to 0.188. Well, there's 0.18, so it's going to be up here somewhere. It's not perfect, but, and let's see. Probably could have drawn this out ahead of time. So there's that. Maybe I can just like shade it a little bit. Okay, and then the next one is 30 to 60. 30 to 60, and I'm going to go to 0.268. So I've got 0.26 and 0.27, so it's going to be somewhere in there. Okay, let's make it bigger so you can see the whole thing. Or smaller, or whatever. Let's make it farther away. There you go. And then, so you just go ahead and, I wish I could fast forward this, but I'm not really into editing. The third bar is 0.24, that's the height. So maybe I can go a little bit faster here. I'm going to check them off as I do them. The next bar is 0.18. So you guys could do this on your own. You're capable. And then the next bar is 0.072. 0.07. I'm just going to put it right around, right, a little taller than 0.07. Hope I don't mess this up. And then the next bar is 0.024, so I'll find 0.02 and then I'll go up a little higher than that. And for some of you that didn't really click with the technology, maybe this makes more sense to you than when we do it on Desmos. The next bar is 0.016. So I'll go to 0.01 and then just go a little higher. And the last bar, oh, I already checked it. The last bar is 0.008. So that's even shorter than 0.01. So it's going to look something like this. I would shade them all, but well, here, I'll just go ahead and shade them all. So there's my bars. I didn't need a computer. I actually did it in my own brain. I could put all the little numbers on the bars. Remember, these are percents. This is like 18.8%. Maybe I should write it as percent. No, I'll write it this way. This is 0.268. This is 0.24. This is 0.184. This one's 0.072. 0.024. 0.016. 0.008. So if I add these up, they should all add up to 1. I actually haven't tried adding them up, but they should all add up to 1. So all that was just letter A. Letter B says, what intervals contain the median, first quartile, and third quartile? So the median is going to be in the very middle of the list of numbers. We know how many numbers are in the list. There's 250. And so the median would be halfway through the list of numbers, which would be the 125th number, because half of 250 is 125th. So if I started adding these numbers up, I could find out which bin the 125th number's in, because that's what they're asking. So I'm just going to start adding them up, like 47 plus 67. Hey, how much is that? So I'm not up, I'm looking for 125. And I actually did some little math right here. It's 125th number. That's what I'm looking for. So the 125th number is not in the first or second bin because those only add up to 114. So pretty sure it's going to be, once I add the 60 to it, it's going to be in this bin, which is the 60 to 90. Let's write that. Letter B. Median is in the 60 to 90 interval. That's what they wanted for letter B, right? And the first quartile, Q1, oh, well, Q1 is a quarter of the data of 250 is actually the 62nd, it's actually 62.5. But I think it's going to end up having to be in this second bin because the 47th number is in this first bin, and then if I add 67 more, I'll have plenty, if that makes any sense. I'll have passed the 60th or 62nd number. So Q1 is in the second bin. What's the second bin called again? The second interval is 30 to 60. And does it want Q3? It wants third quartile. So the third quartile is going to be 3/4 of the numbers. So 0.75 of 250 is the 187th number. So if I so I can just add up the numbers and find out where the 187th one would be. So 47 plus 67. Well, I know I can at least add a few of them. Plus 60. Well, how far? We got 174. We're looking for the 187th number. And 3 bins give us the 174th number. If I add that 46, that's going to go over 187. So it's going to be in this $90 to $120 bin. I know this is a lot of work, this problem. That's why I'm doing it on a video. Might have to do part A and part B. Describe the distribution of the shoe values in terms of center shape, spread, and outliers. I think I can do this fast enough. So I can see that the shape is kind of skewed to the right. The center is probably right in here somewhere, so maybe around 60-ish. We don't really have all the numbers, so let's see what the answer key says. I think it's about 60-ish. It says, yeah, it says the distribution is skewed right, and we can see that by looking at our picture. And you need actual data points to find these values, but the center is about 65. And, well, I thought it was about 60, but we can't really be sure without all the numbers. The interquartile range turns out to be about 60, and I can find that by taking the third quartile and subtracting the first quartile from it. And I don't